Hi, welcome back. We're looking at support systems in animals, and before the break we looked at the hydrostatic skeleton. Now we're going to focus on the box structure, which is like a shell structure. You might remember learning that from technology in the lower grades, and this is the example of the exoskeleton. So soft tissues can be supported, they can keep their shape if you put them inside the box, and that structure around the animal is the exo or outside skeleton. Animals that belong to the phylum Arthropoda, such as insects, spiders, scorpions, crabs, they all have exoskeletons. And you're probably very familiar with these organisms, and you will know that if, just as we said, you could stand on or squish these animals pretty simply, they haven't got anything protecting themselves. If you crushed one of these animals, they would have a distinct crush or breaking, you'd feel, because they have this box-like structure around the outside of them. The substance that makes that exoskeleton is called chitin. Right, there's the spelling of the word. Don't mispronounce it. It's not chitin, it's chitin, and the chitin hardens to make that exoskeleton that encloses all the soft tissues. But the exoskeleton isn't completely solid because it has joints so that the animal can move. And the muscles are attached, obviously not on the outside of the skeleton, but they would be attached on the insides of the skeleton, and they would pull the skeleton and relax, and different muscles would then be able to pull things open and closed. So the muscles and the flesh are inside the box of the exoskeleton. This is a diagram showing you the exoskeleton as being those solid black lines, and then the muscles being attached to the inside to either lower or raise a wing or move a leg, and in fact pull the box open and close to allow for breathing. Advantages of the exoskeleton: it is strong. Right? It's also going to protect those outside tissues from predators and from drying out. So you'll find that animals with exoskeletons can live in drier surroundings, they can live on land, whereas animals with the hydrostatic skeleton couldn't live on dry land. It can also be formed in different shapes. So it's going to be able to allow for special organs to be formed for walking, jumping, and various different mouth parts, cutting mouth parts or sucking mouth parts. All different kinds of structures and organs can be formed out of the substance called chitin. Disadvantages are it's actually, for the relative size of the animal, quite heavy, which therefore limits the size that the animal can grow to. The chitin itself cannot bend, so whenever bending is needed, a joint is going to have to be created in the skeleton, and it's inflexible, so it cannot move at any other place other than at a joint. And chitin is simply a polysaccharide, right? It's very much like cellulose or starch for that matter. It's non-living tissue, and so it cannot grow. And because it cannot grow, it means that every time the animal needs to grow, it needs to discard the exoskeleton in order to increase its size. It discards the exoskeleton, or we say that it molts, and a new exoskeleton then is formed underneath it. But it needs a little bit of time, a few hours, in order to dry and harden, and during that period of growth, the insect or the arthropod is very vulnerable to predators. The endoskeleton is the other kind of skeleton. We're going to be focusing on the endoskeleton in weeks to come, because this is the skeleton that you have. This is the skeleton that is formed inside the body of the animal, and the muscles, just like the shirt and the pants and the skirt, are attached around your coat hanger. The muscles are attached around the outside of the bones of the endoskeleton, and it poses a whole lot of varieties of movements that can take place. It's not going to constrict the growth of the organism. It's a very advantageous skeleton to actually have, and all the organisms that you see on the screen now, the bat, the snake, humans, birds, fish, all the vertebrates have this endoskeleton, and you have the endoskeleton, which is why we're going to focus on you as an organism that has this endoskeleton. And of course you can see the huge advantages that this kind of skeleton gives you. The bones are made out of living tissue, and so they can grow and they can repair themselves if they get broken. They can also protect soft organs inside the body. The animal can grow without losing its support system, and it's much lighter, relatively speaking, than an exoskeleton, so it doesn't limit the size of an animal. And the animals can grow to huge sizes. We can think of dinosaurs from prehistory. We can see how big an endoskeleton can actually allow an organism to grow to. And very importantly, a wide range of movements are available. Remember that we're going to be looking at your endoskeleton in detail next week, so that's what we're going to be focusing on next week. After the break, grade 12s, it's your chance. We're going to be looking at fertilization and pregnancy, so stay with us.